big ideas assignment. So you'll want to go back and enter these later.
Yeah.
All right. Okay, new question here. So these are story problems. These are the kind of the real world problems. Some ways that you might see math used in real life beyond the classroom. It took Emil 25.38 seconds to complete the first part of an obstacle course and 33.94 seconds to complete the second part of the obstacle course. How long did it take Emil to complete both parts of the obstacle course? So again, because it's like part one and then a second part, and you want to see how long it takes to do it together, you're adding those numbers there. Now, the order does not matter when you're adding. So if you want to do 33.94 over 25.38 or 25.38 over 33.94, they're both correct, but on the left is generally preferred. You generally put the larger one yeah, larger one generally goes up top. So this one's a little bit different here. What? Oh, sorry. So just let me know when you're ready to proceed.
Yeah, I'm ready.
Okay. The numbers on right here, when you add 4 and 8, it's 12. Would you agree with that?
Yes.
So you put the 2 down here, but there's a carry of 1 that goes above the 9. So the carry always goes to the next digit on the left, unless there's no more digits.
Yes.
All right, so now it's 1 plus 9 plus 3. That's 13. So you put a 3 here, and then a carry of 1.
Okay.
So it's 1 plus 3 plus 5 is 9. 3 plus 2 is 5. Is that okay?
Yes.
All right. Now I want you to try adding the numbers on the right.
Okay.
I want you to see that it's the same.
Yeah, they're the same.
Yes. Okay. And that's not surprising here. So the order does not matter when you're adding or multiplying. So when you add or multiply, the order does not matter. Okay, let's take a look at another question here. We're moving to subtraction now, and when you subtract, order does matter.
The bigger number goes on top.
Yeah, for now, that generally works. So go ahead and read this one out loud for us, please.
When Min arrived at the arcade, he checked the balance on his game card and it was 20.7 credits. Before he left the arcade to go home, he checked his balance again and it was 3.45 credits. How many credits did Min use at the arcade?
Very good. So you mentioned that you take the larger number and subtract the smaller number. That is true. You do want to line up the decimals when you're adding and subtracting. So go ahead and get this written down.
Okay, I got it.
Now, do you remember what to put in this vacant spot right here above the 5?
A 0.
0. So you cannot take 0 and subtract 5 because 0 is smaller than 5.
So you
which
have to
means,
borrow, yep, from the
yes,
7.
that's right. So the 7 becomes a 6, and you put a 1 above the 0, making 10. Do you feel comfortable trying it from here?
Yes.
Okay.
I have a quick question about this one.
Okay.
Um, there's a 1 left. Do I just put it down or do I?
Yes, the final answer here is well, let me work it out here. It's you have to borrow from the 2, so it's $17.25 or 17.25. Is
Yeah.
that what you got?
Yes.
Great. Very good. So yes, you do bring it down, and hopefully you get the right answer there. Okay. So I'm going to help out here again with kind of just giving you the math operation here, but let me read this next one out loud for us.
Okay.
Sarah took her dog Potato to the vet. The vet put Potato on the scale and said he weighed 37.54 pounds. The vet also said that Potato had gained 2.7 pounds since its last visit. How much did Potato weigh on his previous visit? So sometimes it's better. It's like you almost need to draw a picture. Like here's the current weight is 37.54, and the past visit, we don't know what that is. But to go from that one to this future one, it was adding 2.7 pounds. So to go backwards, the opposite or the opposite of adding is subtracting. So you subtract 2.7 pounds to go backwards. So sometimes the picture is very very helpful.
Yeah.
All right, so we're going to take 37.54 and subtract 2.7, and then you put a 0 here at the end. Will you give that a try, please?
Yes. Okay, got it.
Okay, what is your final answer?
34.90.
Like this?
Yeah.
Okay, so 4 minus 0, though, that is,
0.
so let me write it out horizontally. 4 minus 0, 4 take away 0.
0.
So you have 4 things,
Mm-hmm.
but none of them are taken away from you. So you have
So,
4, you still have 4 things left over.
oh, okay.
Okay, now I believe in the next one you correctly said, okay, 5 is smaller than 7, so I can't subtract, but you can borrow from the 7 and make 6. 15. Now 15 minus 7 is 8.
Mm-hmm.
Okay. And now 6 minus 2 is 4. And the 3 is brought down 34.84. Is that okay? Is that clear?
Yes.
All right, let's try another one like this. Did you say you have a dog?
Yeah.
What is your dog's name?
Gohan.
Gohan. Okay, I want us to spell that. How about how much does your dog weigh?
I would say like 9 pounds.
Okay, so it's a small dog. So
Yeah.
let's say it weighs 9.83 pounds. I'm sorry. Let me change that number here. Let's say that's a little light, but let's say it's 9.43 pounds. Okay,
Mhm.
and he gained 1.5 pounds since his last visit.
Yeah.
Okay, so let's have you try this one. 9.43 subtract 1.50.
Okay. I got it.
Okay, what is your final answer here?
7.93.
Okay, that sounds correct. So you'd borrow from the 9 and get an 8. 14 minus 5 is 9. 8 minus 1 is 7. 7.93. Good. Okay. All right. So let's keep going here. All right. So I want you to read this problem and decide if it's addition or subtraction.
Okay.
So let me go put down here. All right, go ahead and read this to yourself and just let me know what you think, if it's addition or subtraction.
Okay. I think we subtract.
Yes, yes, because if you draw a picture, it's like here's the normal or the regular price, 34.95, but you actually pay this. And so it's like, how did you get from there? You have to subtract. Okay, so let's try that here. 34.95 subtract 19.29. So let's look at this one together here. 5 minus 9, there's a problem with that because the 5 is smaller than 9. So you need to borrow from the 9 up here on the top left. So that 9 goes to 8. The 5 becomes a 15. 15 minus 9 is 6. And then the 8 is bigger than the 2, which is 6. And then you have the same problem again here. The 4 is smaller than the 9, so you borrow from the 3, that becomes 2. And you put 1 there, so it's 14 minus 9 is 5. 2 minus 1 is 15. So that is how much they save by paying the lower price.
Okay.
So the real challenge here is not like doing the addition or subtraction. It's figuring out, is it addition or subtraction.
Okay.
So I want you to look at this next one here and decide if it's addition or subtraction.
Okay.
So let's take a look at this here.
Okay, I think this one's adding.
Okay, so they want to know how much faster lightning bolt's time than Flojo's time. Faster. So they're saying like Usain Bolt,
Mhm.
here's a picture. It took him like that long to do it. And then Flojo, she took that much time. When we want to know how much faster, we're looking for this like difference between them.
Oh, okay.
All right, so we're going to take that that time of the larger one, 10.49, and subtract the 9.58. So go ahead and try this one, please.
Okay.
If you have a question, of course, let me know.
I have one question. I did the 0. Oh, wait. Sorry, I wrote it wrong.
It's okay. I thought maybe you have a question about borrowing on this one. That's why I wanted to
No.
see what you'd come up with, because you do really well when you ask me the questions. You seem to
Mm,
get your uncertainties out.
1. And then we're supposed to borrow from the 1, right? Because the 0
Yeah,
doesn't have anything.
that's right.
And this
So
turns into
the
0.
0 becomes it becomes 10, and then when you borrow from the 10, it becomes a 9, and that the 1 goes above the 4.
Mm, mm. So is it 0.91 or?
Yeah, yeah, exactly.
But we don't have to put the zeros, right?
You
We can
can if
just.
you want. I mean, it's totally up to you if you think that it makes it clearer. But the point is, I think the point they're trying to make is that it's almost 1 second faster for the 100 meters.
Okay.
So it looks like there's a couple more questions here that you might have. Let me just snip them in, and I'll just give you the math operation, and then we'll finish up here. You'll have to work these out on your own. So here we go. This next one, it says this one you're going to end up adding. You can look at
Okay.
that later. That's number 7, number 8. Next one here, you're going to end up adding all 3.
So 7, 8, or 9, or
This is 7, this is 8, and then I get to 9 here. So for 9, you're going to add these 2 numbers, and then you're going to subtract from 5. And then we'll get your brother to jump in here. So this one, you're going to add these 2. And then you're going to take these 2 numbers here and you're going to add,
Mhm.
and then you're going to subtract from
Okay.
each other. But that will probably do it for us for today, Zoe. So
Okay.
I'll see you on Wednesday. We'll just do another lesson on whatever you guys are working on, but let your brother know to jump on in whenever he's ready. And thanks again for letting me help you today. I'll see you next time.
Thank you.
You're welcome.
Hello.
Hey, Michael, how are you today?
Uh,
Hey, Michael, how was your weekend? Hey, Michael. Hey, Michael. Hey, Michael.
Hello?
Hey, Michael, can you hear me now?
Yeah, because the internet connection got lost.
Got it. Tell me something good that happened to you this weekend.
That I get to play the Nintendo.
Say that one more time. I didn't follow that.
I played a game.
Cool. That's great. Awesome. So you got a couple more weeks of class. Your sister told me you guys have your break here in a couple weeks. That's awesome. I'm looking at your lesson for today. It looks like you're doing some more multiplication, but this time it's by a fraction. So let me see if I can find some problems for us to look at. Okay, let me, are you seeing my screen, Michael?
Yeah.
Okay, so I want you to think of this circle here as being a hole. Have you seen that
No.
one hole before? You've not seen that?
No.
Okay, well, that's interesting. Okay, so if I cut the pizza in half, there are now how many pieces?
2.
There's 2 pieces. So the 2 goes on the bottom. That's the number of pieces. And each of these, you can think of each of these as 1 or 1/2.
Oh.
Okay, so let's look at another circle here. Let's say I cut the circle into 3 pieces. So there are 3 pieces here. Each one of them is 1/3.
Okay.
So however many pieces there are, that's the number that goes on the bottom. And then each individual piece is one of them. So let's look at another circle here. How many pieces have I cut this up into?
2.
Nope. How many pieces do you see here? You're going to grab the pizza. You've had pizza before, right?
Yeah.
Okay. How big is how many slices of pizza are there?
4.
4. So each of these is 1/4. Let's draw another pizza. How many slices are there in this pizza?
4.
I'm sorry.
4.
Oops, I did this wrong. That's not right. There's supposed to be 5. Okay, sorry. 3. Okay. How many pieces are there now?
5.
5. So there's 5 pieces and each one of them is a fifth. So you get 1/5, 1/5, 1/5, 1/5, and 1/5. Okay. So here's one for you to try. What fraction goes in each of those slices?
The number, how much it is.
Okay. Well, I'm asking you for an answer. Do you want us to go back and look at a previous problem here? So there were 2 slices here. So we wrote 1/2 in each of them.
Okay.
And then how many slices were here?
3.
3. So we wrote 1/3. How many slices were here?
4.
So what did we write in each of them?
1/4.
Okay. How about this one?
1/5.
Okay. So how many slices do you see here?
6.
So what goes into each slice? What fraction?
1/6.
Very good. Now, the same thing applies to, say, like a rectangle. Now, let's say I have a rectangle here like this, and I cut it in half. What goes in each space?
1, 1, 2 or something.
Yeah, we say 1/2, which is really 1/2.
Okay.
Now let's try this one here. What goes in each of those spaces?
Third.
Thirds. Very good. Okay. Awesome. Okay. Very good. All right. So now we're going to talk about how to multiply fractions. But before we multiply fractions, we have to remember the following. We have to remember how to add fractions. Okay, so let's look at something. What is 1/2 plus 1/2? Do you have any idea?
2. I don't know.
Okay, let's go back to our very first. What is 1/2 plus 1/2? It's a whole. It's the whole pizza, right?
Yeah.
Okay. So 1/2 plus 1/2 ends up equaling 1. But how do we get that? Well, we'll get to that in a bit, but if you recall, you can do 2 times 1/2 to get the same thing. Like if you're multiplying, if you're adding like 5 plus 5 plus 5, this is the same as 3 times 5. You count the number of numbers and you multiply. So 2 times 1/2, to multiply fractions, you multiply the tops and then you multiply the bottoms. So you take 2 times 1 over 1 times 2. What is 2 times 1, Michael?
2.
Okay, and what is 1 times 2?
2.
Good. So what is 2 divided by 2?
2.
Nope. You have 2 things and 2 friends. 2 pieces of candy. How many pieces of candy does each friend get?
1.
1. Very good. Okay, let's try something a little different. Let's try 3/4 times 5/7. So I want you to multiply the top numbers 3 times 5 and the bottom numbers 4 times 7. Can you multiply those numbers for me?
3 times 5 is 15, and 4 times 7 is 28.
Very good. Let's try another one here. Let's try 2/3 times 5/11 this time. I want you to multiply the top numbers and then multiply the bottom numbers.
So 3 times 11 is 33, and 2 times 5 is 10.
Very good. Awesome. So you got that down. Now, where I think it gets confusing is, let's say I want you to multiply 12 times 1/4. And the reason is that 12 is not a fraction. But you can write any number as a fraction by putting it over 1.
Okay.
So now you multiply the tops and you multiply the bottoms.
12 times 1 is 12. 1 times 4 is 4.
Okay, now does 12 go in, or does 4 go into 12? What is 12 divided by 4?
2.
Nope. So remember, division is like multiplication. 4 times what number is 12?
3.
3. Good. Let's try another one here. Let's go let's go 20 times 1/5. So 20 is really 20 divided by 1. Okay, Michael, and then you can multiply the tops and then you can multiply the bottoms. So you can always write a number as being over 1.
Okay. So 20 divided by 1 is 20, and 1 times 5 is 5.
Good. So 20 divided by 5 means 5 times some number equals 20.
Okay.
What is that number, Michael?
10.
Nope. 5 times 10 is 50.
Okay.
What is it, Michael? What is 5 times what number gets you to 20?
5.
Nope.
4.
4. So 20 divided by 5 is 4. All right, so let's try another one here. Let's say it's 30 times 1/6. We can write 30 as what? What's another way to write 30?
Put 1 below.
Yeah, exactly. So 30 divided by 1 times 1/6, you multiply the tops and you multiply the bottoms.
30 times 1 is 30. 1 times 6 is 6.
Good. So now 30 divided by 6 is really the same as 6 times some number gets you to 30.
5.
It's 5. Perfect. Okay, let's try. You ready to try one here on your own?
No.
Well, I think you've got to. Let's try one that's not too difficult. Let's go 10 times 1/2. Go ahead and try that one for me, please.
I got my answer.
Okay, what is your answer?
It is 5.
Yeah, that's correct. So on the top, you get 10. On the bottom, you get 2. 10 divided by 2 is 5. Very good. All right, let's have you try one more here, Michael. What is 12 times 1/3?
I got it.
What is your answer?
4.
It is 4. Very good. Awesome. Okay. So we get time for one more here. Let's go 40 times 1/5.
I have it.
Okay, what is your answer?
8.
Awesome. Hey, great job today, Michael. That was impressive. You really knocked this one out. So we've got another lesson on Wednesday. This will definitely help you towards working your assignment, but I thank you. That is it for today. I will see you on Wednesday.
See ya.
Okay, bye.